Hello there, and then welcome to a brand new video. This Hub Beyond Numbers, where we learn maths the easy way. Now in this video, we are looking at the power. We are still on the laws of indices, but then this time around we are looking at the power of a power and then the zero index. And after all this, you'll be able to apply the power of a power of indices in solving equations and then understand how to use the zero index rule. Without much I say, let's quickly look into it. So the third rule we are looking at is the power of a power. And for that, it says if you have any base, so you have A and it's raised to the power an M, that is any index at all, you see, provided there's also another exponent on this whole index notation here, that is if you have N outside here, then how do you evaluate it? It is just your A, then you multiply the index you have there. So M times N, as simple as that. You see, so when you raise a power to another power, just multiply them. You get it? So how do we apply this in questions? Let's take some questions and then simply explore. But before this, if you just want to apply the laws of indices we've done here, it means you have A to the power M multiplying itself n times. Let's take some examples and you get it clearly. So this first example here, it says we have 2 raised to the power 3 and all to the power 2 as well. What does this mean? It means you have 2 raised to the power 3 multiplying itself 2 times. You see, now if we are to use the power of a power law over here, then all it is saying we should do is we have 2 raised to the power 3. Let's multiply the 3 by 2. You see, and 3 times 2, it gives us what? 6. And from our basic indices, we know 2 raised to the power 6 simply means 2 is multiplying itself 6 times. You see, and that should give you what? 64. So here we can say that 2 raised to the power 6 is just what? 64. And that is our final answer. Get it? So this is how we actually use the power rule. But earlier on, I was saying that this 2 raised to the power 3 all squared simply means you have 2 raised to the power 3 multiplying itself again. So a number, how many times? Just 2 times. We have 1, 2. You see that? That is what this notation here means. And assuming we were to use the product rule, we would have said 2 to the power 3 plus 3, because we are multiplying and then we have these indexes and they have the same what? Base. And would have also continued to get 2 to the power 6. But since we don't want to go through all this stress, that is where the power rule comes in, which says that we should just multiply the index notation by what you have on top. So just multiply the index. Let's take some few examples. So over here we have x raised to the 4th power or raised to the what? 3rd power. So what do? We just evaluate the exponent. So that we are going to get x raised to the power 4 times 3. You see, and 4 times 3 we know gives us a 12. So we have x to the power 12. As simple as that. Hence, let's solve one last question. This one is a little bit tricky because you are applying something. Now, let's take a look at this over here. It says we have a raised to the power 3. And this a raised to the power 3 is also raised to the power 2. And this raised to the power 2 is also raised to another 2 as well. How do we evaluate this? Most of the times, all you know in the basics if you understand it well, that is what you apply as you move on, you see. So we know that the power rule is saying that if we have an index that has a base, that if you have an index notation that has another power, multiply the powers. So let's multiply this here by this, so that we are going to get what? A 3 times 2, all squared, you see. So with this, we have evaluated this one here. We have evaluated the one you see in the yellow color or gold color, whatever you see it is. You see, then now we are left with this 2 over here. We know 3 times 2 gives us a 6. So you have a to the power 6 all squared, you see. And this again requires us to apply the power rule. So you have a raised to the power 6 times 2, which gives us what? A 12. As simple as that. Okay. Now, with this done, let's look at the zero index. I spoke a little bit of the zero index in our introductory video. All it says is if you have any base and it is raised to the power 0, then it is equal to 1. Any non-zero number that is raised to the power 0 is equal to 1. It simply means a should not be 0. No. So apart from that, any non-zero digit that is raised to the power 0 is 1. These are very, very simple. And all it simply means is if you have 3 raised to the power 0, it is what? 1. You see that if you have x to the power 0 is equal to 1. And if you are asked to solve for x, x can be any number apart from 0. 10 raised to the power 0 would also give us what? 1. Now let's look here. What of 5 raised to the power 3 all to the power 0? What answer is it going to give us? Now you are going to apply the product rule here. So you have 5 raised to the power 3 times what? 0. And that ends up giving you 5 raised to the power 0, which is also 1. You get it? So anytime you solve index notations, you are getting a power of 0. It simply means what? It is 1. This property is very useful when solving equations. And as you would see, we would solve some equations and we would get to apply them. In our next lesson, we'll be looking at negative indexes and then fractional index. Stay tuned. Now, these are some exercises you can try to test your understanding on what we have done on this lesson. So as you can see, we have these 2 sets of questions over here, which applies all we've done in this lesson. And I believe you'll be able to solve it. See you in our next lesson and stay blessed. Bye.